The reason for this video section is to show the indicator being set up for measuring in angle mode instead of linear mode. When we talk about linear, we mean that when the indicator is mounted onto the shaft and you are turning through continuously in one direction, it will count up. When you turn it in the opposite direction, it counts up, and importantly, when it gets to 0, it will start counting negatively, as you can see. However, if the indicator is to be applied in angular mode, it requires on the application that the indicator starts counting down in angle from the 0 point. So it will count up in degrees, and then as you go through the 0 point, we want it to start counting 359, for example. So what we do is we go into the parameters, and we first, via pressing the P button for the 5 seconds, then as you can see here, we've set it to 1000. In angular mode, we need to change this to 3600. So we move along the digits till we get to the third one. We can change this now by pressing the up arrow to the 6, then head further to the left and change this to, sorry, I've gone through it, but we'll change it through again to 3600. We store that value by pressing the star key, head down via the P button further through the parameter list to the decimal point, which is in the correct place. So now after the revolution, it will display 360.0, meaning 360.0 degrees. So we head further down until we come to the node parameter, and that is set to linear. We change that to 360, which is the angle setting. Press the star button. That's registered the change. Now we head out to the position value, can then 0 it, and we can now see that as we turn through the one turn, we will go to 360, and then it resets to 0. So this is a great feature of the display. Once you've set everything up, a lot of applications, the machine maker or the user doesn't want any operator to potentially go in and change any of the parameters that have been set, because that could mess everything up. So what we've done is we've put a feature in there of being able to lock everything off, and unless you put in a PIN code to allow you to access the programming again. So you have to go in and set this. So we go into, press the P button again into the programming parameters, 5 seconds, go down to the PIN parameter. It's off at the moment, so that means everything's freely accessible by anybody, and you change that via the arrow up button to on, register the change via the store key, and then you can come out of there. So now when we press, or anybody does, the operator for example presses the P button, it asks for the PIN. The PIN we can then enter, move across, to this value. We press the star button to register that, and now we're into the parameters to allow us to change the programming. But without that PIN code, you can't get in. How to work in relative, or what we call incremental mode. And this is for applications where, for example, you've got a shaft that rotates, and along that you're moving a block to position the part, and then you might want to drill at a certain point on the shaft. So for example, if we say we turn to a position, and at this point, say for example 15 millimeters, we want to make the first drill or cut, and then we want to then move the next position relative to the last position, not from the 0 point. Then what we do is we would switch the function on, that we can use it and go into relative mode. So we press the P button for the 5 seconds, step down by the P button to the incremental function, which is the F-OFS, and we then switch that on, which it is, that's the off position. So if we switch it on and press the star button to register the change, then if we come out, we're at the 15 millimeters. So if we then press the arrow up and the arrow across button together, we then zero the display in relative or incremental mode, and you should be able to see the arrows there as well. So then we can move, say for example, another 10 millimeters. So we make the next cut or drill at 10 millimeters. And then once we've done that, we can then press the 2 arrow buttons again, and those values will be added together. So we still know we are 25, in this case 0.1 millimeters, away from the 0 point on the machine. The reason for this video is to show you how to set a number of offset values, because for example in the application the customer wants to change to a different number of tool sizes. So what you have to first do to release the function in the keyboard, so you don't have to go into the parameter mode every time you want to change the value, you enter into the parameter settings via the P button. You scroll down by pressing the P button till you get to the function offset mode. You then change it from off to on via the arrow up button, and you then press the star key to register the change, and then you can come out to the current display. If you turn to a position, and we'll check to see if there's any offset value in by pressing the star button, there is nothing in there at the moment. By pressing the P and the arrow across button together, we then enter into an offset mode without going into the program mode, and then we can change the value. So we'll change it to add, for example, 10mm blade on there. Press the arrow up to change it to the 10mm, remembering there's a decimal place there. Press the store key, and then we can come out. When we press the new value, we can move to a position. When we press the star key, we'll see that value in. Here we'd like to show you how to change the decimal place. Enter the parameter list via pressing the P button for the 5 seconds. Move down the parameters via pressing the P button again to the decimal place shown here is 0, and this time we'd like to move it to 2 decimal places. So we move across, press the star button to register the change. We move down now out of the parameter list. You can see the decimal place has changed. So what we'd like to show you on this video is how to enter them into the parameter mode in the programming, and we do this by pressing the P button. And we have an application requested by one of our customers where he wants to set the display per revolution to 100 millimeters. So what we're going to do is we're going to move to the left the display and change the digits via the arrow up button till we get back through the 0 and back to 100. And we must press the star button after we've made every change. That's now registered. We then want to check that the decimal place is in the correct place. It's not in this case, so we want to change it to no decimal places. Again, we recognize the change by pressing the star button, and then we can come out of the programming mode back to show the position, current position. When we turn the shaft through one turn, 360 degrees, we have the display showing 100. Firstly, we'd like to show you how to step through after entering the programming mode. So by simply pressing the P button for typically 5 seconds, you'll see you're now entered into the parameter menu, and you then step through by pressing the P button. You can see each parameter changing right away through to the end without making any changes. This video will show you how to set the datum value, or what we call a reference value, on the indicator. So again, you go into the programming mode via the P button for 5 seconds, enter the parameter list, step down till you come to the shown as a calibration, which is a calibration datum or reference value. So it's normally called the absolute calibration point on the machine. So for example, if we said, right, we can only get the shaft position to for example 100 millimeters to the tool, where you're going to cut the point where it would be 0, then you go along, you change that to 100, and you register it with the star button, and then we move out. And then what you'll find is now, when we move the shaft to a position, we come up against a stop on the machine, and we press the star button. That sets it to 100. So in this video, we'd like to show you how to change the direction of the count. Here you can see, if we turn the shaft clockwise, the count and the display increases. We want to change this so that it decreases when we turn it clockwise. So we go into the programming mode via the P button, typically for 5 seconds, pressing that. Enters in, we step down by the P button to the DIR. This is the direction parameter. We change it from the I, which is increasing clockwise, to the E. The change we register by pressing the start button, and then we move down and out to the value. Zero it, so we know the change has been made. Now when we turn it clockwise, the value decreases. If we turn it anti-clockwise, it increases. In this video, we'd like to show the reason for using a divisor, which is called a dividing factor. Typically, for example, if we take a movement of 3.5 millimeters after one revolution, the customer in this case says that he doesn't want to register the tenths of a millimeter, but of course he wants to display the change after a number of revolutions. So we go into the programming mode and we would change the display after one revolution to show the 3.5. So we would set the display to 5 and then that one by pressing the arrow up button to 3. Then move along and change the third digit in to 0. Press the start button to register the change. Then move through and set the divisor to 10 instead of 1. So effectively this will still register the 5 in the ratio, but it won't be displayed after the first revolution. The reason for this video example is to show you how to go into the parameters and set the function of the star button as far as on the machine to datum it, to enter that calibration value, and there's 3 modes for that, and as we go into that parameter we can show you this. So if we press the P button for 5 seconds, start, once we're in there, going down to the value after the, or the parameter after the calibration, which is the reset value. So at the moment we've got it on. We can change this to off. We can set it to 5 seconds. So we'll set it to 5 seconds. We register the change by pressing the start button, and then we come out. This means that when we move the axis to a position and we now want to datum, calibrate, reference, whatever we want to call it, when we press the star button just for a short period, nothing happens. If we keep our finger on the button for 5 seconds, the axis will be datumed. If we go back in and said we didn't want this function, anybody to change it once that value has been set, so we move the axis to position, we set that by pressing the star button, 5 seconds, we've datumed the axis. We then go in to the parameter again, scroll down to the reset function, we then switch the function off, register it via the star button again, come out, the value hasn't changed, we move axis, and now when we press the start button, there's no function if we keep our finger on for longer than 5 seconds. The value doesn't change, it can't be tampered with unless you go into the programming mode again.